Hello and welcome to Math with Lou. Today we are going to be talking about performing calculations with the real numbers. We're going to be going over the big four mathematical operators: addition, subtraction, multiplication, and division. Alright, so let's dive right in. So here we have the first one, addition. Uh, I want to start off in talking about how when we add real numbers with the same sign, the sum will have the same sign as the added numbers. So we can see here I have two different examples. 4 plus 3 both have the same sign as positive. We add those up and our answer is a positive 7. Likewise, a negative 8 plus a negative 3, which one thing I want to make a note of that is very important is this is actually the same statement as negative 8 minus 3, but both of these signs are the same, so when we add these two together, the number that we are going to get out will also have the same sign. Let's erase this here. Okay. When adding numbers with different signs, you subtract the lesser absolute value from the greater one. The sum will have the same sign as the number with the greater absolute value. A lot of jargon going on here. Let's explain this simply what this means. So absolute value is simply just the positive of a number. So right here we have negative 8 and 3, but if we just look only at the absolute values, the 8 is greater than the 3. So because this negative 8 has a higher absolute value, we know immediately that our solution will also have a negative, and again, because this is the higher absolute value. Likewise with this one over here, with negative 1 plus 7, the positive 7 has the higher absolute value of the two terms, so we know that when we add them, our answer will also be positive, again, because this absolute value is greater than this one. Now we have some properties of addition I want to go through. All of these very, very important, very easy to gloss over and forget about. But these are, like I said, very important when we talk about what we're doing with our orders of operations and whatnot. So the first property I want to talk about is addition. The commutative property of addition, which states that a plus b equals b plus a. The order in which we add terms does not matter. And when I put an example right here, 1 plus 2 is the same thing as 2 plus 1, give us a solution of 3. Again, commutative property, order does not matter. The next property we're going to talk about is the associative property, which states that the order in which we group numbers does not affect the sum. The order in which we group them makes no difference. We're going to get the same solutions. The general rule for that here is in parentheses a plus b plus c is equal to a plus parentheses b plus c. And here in the lighter green, I have an example worked out. 1 plus 2 plus 3 is the same thing as 1 plus 2 plus 3. Order of operations, we do it inside the parentheses first. 1 plus 2 is 3, so now I have 3 plus this 3 here is the same thing as 1 plus the 2 plus the 5, or sorry, the 2 plus the 3, which gives us the 5. So 3 plus 3 equals 1 plus 5 equals 6. As we can see, it's super evident that the way we group these doesn't make a difference. Addition, we're going to get the same answers. The identity property of addition. This is very important just for when you talk with somebody about what you're doing in math. In algebra, it's a good idea to understand what this means because when we solve for variables and do things of that nature, what you're actually doing in your simplification process involves the identity property. But the words, yeah. Anyway, all right. So the identity property of addition is defined as the sum of some number and 0 is always that number. And I put in parentheses here so that you know that 0 is the additive identity of addition. So some number a plus 0 equals that same number a. Here's an example with hard numbers: 5 plus 0, 5. So again, the important thing to take away from this is that 0 is the identity property of addition, and when you add 0 to any number, it maintains its same value. Next we're going to look at is the inverse property of addition, and this is my last of the addition properties. The inverse property of addition is defined as a number plus its opposite or negative will always equal 0. And I forgot to put a little parenthesis here, but the number's negative is its inverse. So here's an example with variables and another example with numbers. A plus negative a is 0. Negative a is the additive inverse of a. Likewise, 2 plus negative 2 equals 0. Negative 2 is the additive inverse of 2. And just one more quick little example. If we have, I don't know, negative 3 plus 3 equals 0. Now the positive 3 is the additive inverse of the negative 3 because it gives us this sum of 0. So it's not always the negative of a number, but the opposite sign, because as we can see here, the opposite of a negative 3 is a positive 3. Add these, 0. All right. Next on to subtraction. Not much to say here. As you can see, I literally only have one little blurb. When subtracting a number, it is the same thing as adding its negative. And I made a general rule for that here. A minus b is the same thing as a plus a negative b. Example, 11 minus 3 is the same thing as saying 11 plus a negative 3, which we know is 8. One thing I want to comment on is you notice here when I write the plus negative, I put the negative in parentheses. It's considered good etiquette to do that. If we see something like a plus minus b, this is ugly. We do not want to work with something like this. We don't put two signs right next to each other. We break them up with something. So in this case, those signs are broken up with parentheses. A plus a negative b. Okay. All right, multiplication. We have a lot to talk about here. First thing I mentioned has to do with the signs of the product of numbers. And I wrote here, the product of two real numbers with the same sign is always positive. A positive times a positive is a positive, and a negative times a negative is a positive. We know this. This is pretty evident. Double negatives cancel each other out. Two terms, same sign, multiply them together, always positive. This holds true if you multiply more than two numbers. If you multiply with any odd number of negative numbers, then the product will be negative. And here's an example. We can see here we have 1, 2, 3 negative numbers and 2 positive ones. The amount of positive ones don't even matter. All we care about are the negatives. Because there's an odd amount of negatives, our final answer is negative, not odd. Likewise, if you multiply it with an even number of negative numbers, the product will always be positive. And here we have an example here. We have two negative numbers. The double negative cancel out, becomes a positive. 2 times negative 3 times negative 1 is the same thing as 2 times a positive 3. Just gives us a value of 6. All right. So now we have the commutative property of multiplication, very similar to the commutative property of addition, likewise with the associative one. But the commutative property of multiplication states that the order in which you multiply numbers does not affect the product. So a times b, same thing as b times a. Example here with some numbers, 2 times 3 gives us the same value as 3 times 2, 6. Associative property of multiplication. The order in which you group 3 or more numbers does not affect the product. So just like the associative property of addition, the grouping doesn't matter. A times the quantity of b times c is the same thing as the quantity of a times b times c. And I have an example worked out here with some hard numbers. 2 times the quantity of 3 times 4 equals the quantity of 2 times 3 times 4. We do the parentheses. 3 times 4 is 12. 2 times 12 is equal to, well, 2 times 3 here is 6, and then we have the 4. So 6 times 4 equals 24. 2 times 12 equals 6 times 4 equals 24. The way we group things for multiplication does not matter. And actually, so these associative properties for both addition and multiplication, very, very, very important later on in algebra, especially when you get to factoring, trinomials, or 4-term polynomials. The factoring by grouping method involves us utilizing this property. All right, the identity property of multiplication. So if you remembered before what I said about the identity property of addition, it is a number such that you add to another and it maintains the same value. So 1 plus 0 is 1. 1 is the identity the identity for addition. The identity for multiplication is always going to be a 1. And that's because any number times 1 maintains the same value. 6 times 1 is 6. So we could see how whenever we apply the identity to a number, we always get that number back out. In addition, the identity is 0 because any number plus 0 is the number. In multiplication, the identity is 1 because any number times 1 is that number again. The inverse property of multiplication, which this is a really good way of looking at division also, but a number multiplied by its reciprocal is always 1. And I made a comment here, which we're going to get more into the reciprocal and division, but the number's reciprocal is its multiplicative inverse. So here I have an example of that. Whenever you have any number, any constant that is a integer or natural number, the reciprocal is always 1 divided by that number. So any number times 1 over that number is always 1, and here we could see an example with 7s. 7 times its reciprocal, 1/7, equals 1. And we can show that in a little more detail, how this is 7 times 1 over 7 is equal to 7 over 1 times 1 over 7. Now we should have learned that when we multiply fractions, we just multiply numerator to numerator, denominator to denominator. Oops, I like the other blue. And so this will give us 7 over 7, which we can see clearly is 1. Okay. So now the next thing I want to talk about in terms of multiplication, and the last thing, is the multiplicative property of -1. This one's pretty important, especially for when we're solving for variables in algebra. If you get like a negative x equals 10, we're not solving for negative x, we're solving for positive x, so we can utilize this property to make x positive. So this property states that the product of a number and a -1 has the opposite sign of the number. A times -1, negative a. If it was a negative a times -1, then it'd be a positive a. And I did an example like that over here. 2 times -1 is -2. -2 times -1, positive 2. Multiplying any number by -1 changes the sign. All right, lastly, we are going to talk about division. So I brought it up before, the reciprocal, very important to know. The reciprocals are numbers that when multiplied have a product of 1. So we could see here a over b, its reciprocal is b over a. We multiply these through, we get ab over ab, same thing as 1. And here's an example with hard numbers. 2/3 times its reciprocal, 3/2, gives us 1. And again, we could show this out in more detail if we want to see it. 2 times 3 times 3 over 2. Well, this equals 2 times 3 over 3 times 2, which equals 6 over 6, which is, bam, 1. Okay. So another note here, dividing by a number is also the same as multiplying by its reciprocal. Okay, so I made a comment over here with that with the general rule. A divided by b is the same statement as a times 1 over b. Again, this is so important. This is so useful later on. Sometimes it's honestly much easier to think about division as multiplication of reciprocals. Honestly, most times it's easier. But we can see here a divided by b, same thing as a times 1 over b, which is simply a over b. And then here again, I did an example that hopefully this one, my goal was to make it pretty obvious. 6 divided by 3, well, we should know we should get 2 out of that. Again, that's an easy one. But again, we're going to look at it as multiplication of the reciprocal. So 6 divided by 3 is the same thing as 6 times 1 over 3. We multiply the 6 into the 1, and that gives us 6/3, which we know simplifies to 2. Okay. More comments about signs. The quotient of two numbers with the same sign is always positive. Just like with multiplication, the product of two numbers with the same sign is always positive. Same thing here with division. The quotient of two numbers with the same sign, always positive. 12 over 3 equals 4. Negative 12 over negative 3, positive 4 also. And then likewise, if one of the signs is negative, our solution will be negative. The quotient of two numbers with different signs is always negative, like I just said. Negative 25 divided by 5 equals negative 5. Likewise, 25 over a negative 5 still equals negative 5. All right, and we got the last few things I want to talk about here. 0, both of these have to do with. So this one, the first one I read is the quotient of 0 in any non-zero number is always 0. 0 divided by anything equals 0. 0 over x is 0. 0 divided by 1,000 equals 0. We are allowed to divide a number from 0. But what we can't do is divide 0 from a number, bringing me into the final thing I want to talk about. Since 0 does not have a multiplicative inverse, we cannot divide anything by 0. X over 0, can't do it, doesn't exist. 1,000 over 0, doesn't matter, can't do it, doesn't exist. The old joke is only Chuck Norris could divide by 0, but even he can't do that. All right, so that's everything I wanted to talk about today in terms of our big operators: addition, subtraction, multiplication, division. Thank you so much for joining me today, and I hope to see you next time. Take care.